Hello students. So in the previous videos on circles, we learned a lot about the various theorems. We covered every theorem in that chapter and we covered also like how that theorem can be proved. So after doing all that, we haven't practiced even a single problem, right? So that is why in this video and in the upcoming ones on the chapter circles, we will practice a few problems to better understand and retain those theorems. So we'll start with the end of chapter exercise, which is on page 114 of your NCERT maths book, Ganita Manjari. So before we start doing, the questions in this exercise, we will first of all revise all the theorems that we had done in the earlier videos, right? So just to refresh all the theorems, I have listed down all the 12 theorems were there in this chapter. So I had made a 4-part series on circles explaining all these 12 theorems, okay, how we can prove those theorems. So just go and take a look at that in case you want to understand the concept behind these theorems. If you have already covered those, then we can just do a quick refresh of these theorems. And then when we are attempting the questions, we will see how and where these theorems are applied. Okay, so the first theorem was there is a unique circle passing through three non-collinear points. Non-collinear points are the points which are not in a line, right? So which a line cannot pass through all the 3 points. Those are non-collinear points. So through these three non-collinear points, only a unique circle can pass. Second theorem was equal chords of a circle subtend equal angles at the center of the circle. Simple. Third theorem was chords of a circle that subtend equal angles at the center are equal. Next, theorem 4, the line joining the center of a circle and the midpoint of a chord of the circle is perpendicular to the chord. Now this is a important one. Okay, I'll just pick this. This is a important theorem that you should remember because you will get many questions based on that. So you should always remember that if you have a line which is joining the center of the circle and the midpoint of the chord of the circle, it is perpendicular to the chord, and same holds, opposite or converse of this theorem. Okay, this is saying that chords of a circle having same length are all at the same distance from the center of the circle. So not this, but if a line joining, converse of this theorem, that line joining center of circle and midpoint of chord is perpendicular to the chord. So similarly, if we are drawing a perpendicular from the chord, perpendicular to the chord from the center of the circle, it is dividing the chord into two equal parts. So that is basically these two things you need to remember about this theorem 4. Okay, so chords of a circle. Okay, that is, I think I missed the fifth theorem. It should have been the converse. Okay, so that is why I was thinking, where did that one go? So there should be a theorem 5 here. Let me write it down. Okay, I have written down that theorem. So theorem 5, it is the converse of theorem 4. The perpendicular from the center of the circle to a chord of the circle bisects the chord. So this is also a very important theorem. Now chords of a circle having the same length are at the same distance from the center of the circle. And chords which are equidistant from the center have equal length. So these two are converse of each other. If you remember one, you can automatically make out the other. Okay, so theorem 8 is if AB and DE are two chords of a circle and AB is greater than DE, then distance of center C to AB is less than the distance from C to DE. Basically, the longer chord will be at a smaller distance from the center. The smaller chord will be at a longer distance from the center. So this is also which we have already seen the how and why this happens. Now, theorem 9 is this is also a very important one. Now, this is actually important from your Olympiad's point of view, because you will definitely, in the competitive exams, if you get a question on circle and specifically anything which is utilizing these theorems, this theorem 9 is the most likely one that you will get. Okay, and if you are getting one on the concyclic quadrilaterals, then it will most likely be using this. Okay, so these two are very important from the competitive exams perspective. So what does this theorem 9 says? Angle subtended by arc at the center of the circle is double of the angle subtended by the arc at any point on the circle outside the arc. Okay, and theorem 10 is if line segment AB joining 2 points AB subtends equal angles at 2 other points CD that lie on the same side of AB, then the 4 points lie on the circle. Basically, we are saying they are concyclic. Then sum of opposite angles of cyclic quadrilateral is 180 degree, and last is two angles, opposite angles add to 180 degree, then that quadrilateral is a cyclic quadrilateral. Okay, so let's now start with our end of chapter exercises. Okay, so this is the first question. In a circle, a chord is 5 centimeter away from the center. If the radius of the circle is 13 centimeter, what is the length of the chord? So here, first of all, we have drawn this circle with center O. Okay, and then we have drawn this chord. Okay, so this is the chord. We don't know the length of the chord. We just know we have been given that it is at a distance 5 centimeter from the center. And the radius of the circle is 13 centimeter. Now, if we are drawing, if we are saying that it is 5 centimeter from the center, then this distance is always the perpendicular distance that we are talking about. So this is a perpendicular line. Now, what did we study about this? A perpendicular line drawn from the center to a chord. There was something which we have learned in the theorems about this, right? Let's go back and see. So this is the theorem 4. No, this is the theorem 5. The perpendicular from center of a circle to a chord of the circle bisects the chord. This means here this line should be bisecting the chord. What this means is this distance is equal to this distance, right? And this is perpendicular. So this means what is this triangle? This triangle is a right angle triangle. So when you have a right angle triangle, just a second. Okay. So if you have a right angle triangle, then we can say OAB is a right angled triangle. Okay, because this is already given to us, right? That the distance, I'll call it, let me call it OC. Okay, so this is C. So our triangle, this OAB is a right angle triangle, and we have been given OC is 5 centimeter and OC will be perpendicular to AB, right? Because it is the distance that has been given from OC to AB. It's perpendicular, and that is the reason it is a right angle triangle. OA is the radius, and it is also 13 centimeter. Now, what we can deduce from here is, because it is a right angle triangle, we can apply the Pythagoras theorem. This Pythagoras theorem is the most common theorem wherever we see a right angle triangle. You can think, there can be a, it's not 100%, but there can be a case where we are utilizing the Pythagoras theorem. So you should remember that very well. So by Pythagoras theorem, we can say that the square of OA, we can say OA square is equal to, okay, so we can say OA square is equal to what? OA square is equal to OC square plus AC square, right? This is the Pythagoras theorem that we have learned for a right angle triangle. So now in this case, we need to find out AC. So AC square will be OA square minus OC square. So what do we know about this? OA is 13 and OC is 5. 13 square is 169. 5 square is 25. So this is 144. 144 is the square of 12. So this means AC will be 12 centimeter. Now, what is the theorem which we had utilized? I won't write the complete theorem. I'll just point out the theorem. So perpendicular from the center of a circle to a chord of the circle bisects the chord. So this is the theorem 5 that we are utilizing. By theorem 5, you need to write the full theorem when you are writing in the exam. Okay, so AC is equal to BC. So this means BC is equal to 12 centimeter. Now this chord AB is the sum of AC and BC. So this is 12 centimeter plus 12 centimeter. So it should be 24 centimeter. So length of the chord is going to be 24 centimeter. This completes our question 1. So let's start with question 2. An arc of a circle subtends an angle of 70 degree at the center. What is the measure of the angle subtended by the arc at a point on the circle? So whenever we are given a question, so in your book, when this question has been given, the diagram is not drawn. So you should first of all draw a diagram. Okay, so we need to draw a circle with center O, and then you draw an arc. So this arc is AB in my case. Okay, and see what angle it makes with the center is 70 degree. So this is what we need to write here. Then we need to see what is asked of us. What is the measure of the angle subtended by the arc at a point on the circle? So we take any point here on the circle. You can take a point here, you can take a point here. So you can take any point on the circle and you can draw a, you can join that point with the endpoints of the arc. Now you have to remember that your point should not be, on this side, right? It should be on the other side of the arc. Because if it is on this side, then you won't be able to figure out. I mean, all these questions must be based on one or the other theorem. And our theorem, it does not say anything about a angle which is subtended by a point on the same side of the arc. It always says about other side. So if there hasn't been anything written on it, it means it is on the other side, right? So here, what is the theorem that we are utilizing here? Go back, see. So when we are talking about arc and the angle subtended by it at the center, see, this is the one. right? Yeah. Angle subtended by an arc at the center of the circle is double the angle subtended by the arc at any point on the circle outside the arc. So this means by this theorem, this is theorem 9, right? So I will simply write, okay, I have simply written this, but in your exam, you need to remember the theorem and you need to state the theorem, okay, so that after that only you should proceed. So here by this particular theorem, I'll call this point D. Okay. So by this theorem, our AOB angle, which is the angle subtended by arc AB at the center, this should be twice of the angle. And right here, angle AOB is twice of angle ADB. Okay. Now we have already been given that this AOB, right, this is 70 degree. So this means that ADB, so I'll write here AOB is 70 and this is twice of angle ADB, which means angle ADB will be, this is 2 into angle ADB, right? So angle ADB will be half of 70 degree of 70, and that is going to be 35 degrees. Easy. So that is what, even you know the theorem well, it will, and you are able to figure out which theorem applies in this question. The question will be very, very easy for you. Okay, and these are some of the easiest questions from this chapter. Okay, we'll see the next question now. Okay, so the third question is, the diameter of a circle is 26 centimeter, right? So here again, you have not been given a diagram, right? So the first thing that you need to do is draw the diagram. So we're talking about circle. First of all, draw the circle. Then we have been given diameter of a circle is 26 centimeter. So from the center of the circle, you draw the diameter. So here I have drawn this diameter, and I think I should name it. Let me call it this diameter as AB. Okay. And then we have been told a chord of length 24 centimeter is drawn in the circle. So next we need to draw a chord, and you see 26 and 24, they are very close in length. So this means the chord is very close to the diameter. So here I have drawn it. Let me call it, C, and let me give it the name. Okay. I'll call it D. Okay. So this is not coming correct position, but just okay, maybe. Yeah, this is actually the correct position. But this is D. Okay. Now, so I have been given chord of length 24 centimeter is drawn in the circle. I have drawn this chord of 24 centimeter. Now the question is, find the distance from the center of the circle to the chord. So center is O, and we have to find the distance from the center of the circle to the chord. What I had told you, whenever we are told we have to, this is the distance from the center of the circle to the chord, it means it is the perpendicular distance. So we draw a perpendicular from center to this chord. Okay, and now we have been asked, and let me call this, we have called it CD. I should call it E. Okay. So now we have to find the distance from the center of the circle to the chord. So from O to E, this OE is something that we have been asked to find. Okay. Now, again, what is it that you see here? One, the most important one, I told you, right, from your questions point of view, few theorems are very important. And one of those is perpendicular from this theorem 5, perpendicular from the center of a circle to a chord of the circle bisects the chord, right? So we need to remember that this E, what is it doing? It is dividing this chord into two equal parts, right? Another thing, what I told was, we are drawing a, right angle, a perpendicular bisector. So there should be most likely a right angle triangle somewhere. Okay. So if we join this O to C, what will be the length of O to C? What is O to C? OC. This is the radius. So now what we have been given here is diameter AB is equal to 26 centimeter. So this means radius of the circle will be 13 centimeter. What else? What is the radius here? We have drawn OC. So OC is 13 centimeter. What else do we know? We know CE is equal to DE, right? Why? How do we know that? We know that from theorem 5. I'm not going to write the theorem, but in your answers in the exam, you should write it. Okay, now we see a right angle triangle. What is the right angle triangle? Right angle triangle here is OCE, and we learned, right? For right angle triangle, most likely there must be Pythagoras theorem that we are applying. Theorem. What is the Pythagoras theorem? What will be it? OC square is the hypotenuse is equal to OE square plus CE square, right? Now we know the length OC. What is it? OC will be 13 centimeter because this is the radius of the circle. The length of diameter is 26 centimeters. So radius is half of diameter. It is 13 centimeter. OE is something that we need to find out. And CE. CE is, E is the midpoint, right? I have written CE is equal to DE and it should be equal to half of CD, right? So by that, so this means each of them will be equal to half of CD. Length of CD is 24 centimeter. So this is going to be half of 24 or 12 centimeter. So here we are saying CE is 12 square. Okay, now 13 square is 169 and we don't know about OE square. Let's leave it as is. 12 square is 144. Then our OE square is going to be 169 minus 144, which is 25. 25 is the square of which number? 5. So this is 5 centimeter. So distance between the diameter and the chord is 5 centimeter. So with this, we are done with the third question. Easy peasy. Let's move on to the fourth question. Fourth question is, a circle has a radius of 15 centimeter. So let's draw a circle and then the circle is with center O and I have drawn the radius OA of 15 centimeter, right? And then a chord is drawn. So I drew a chord AB. The distance from center of the circle to the chord is 9 centimeter. So when we say distance, it is the perpendicular distance. So this is perpendicular. And let me give a name also to this. So I'll call it C. Okay, so this is C and the length OC is 9 centimeter. Now what is the length of the chord, right? So here we have been given radius OA is equal to 15 centimeter. What else is given? Chord AB is drawn, but we have not been given the length of the chord. Then we have been given the distance from center of circle to the chord. So this is OC and OC is 9 centimeter. And we also know that OC is perpendicular to what? It is perpendicular to AC. Sorry, AB. Right? So we can very clearly see here what kind of triangle is this OAC? This is a right angled triangle. So write this right angle triangle. What did I tell about this? That mostly we'll be using the Pythagoras theorem. So with Pythagoras theorem, let's apply that. Pythagoras theorem, we have OA square will be equal to OC square plus AC square. So this is going to give us OC. This is 15 square, OC square is 9 square, and AC square is something which we don't know and we need to find out. So 15 square is 225 equal to 9 square is 81 and AC square is something which we need to find out. So here what we'll do is we'll write AC square is equal to 225 minus 81, which is 5 minus 1 is 4, 12 minus 8 is 4, and this is 1, 144. So 144 is the square of what? We know already, right? It is 12. So AC is 12 centimeter. Now, what is the property? AC is just this portion, right? And we need to find the length of the chord. So length of the chord AB is equal to AC plus BC. We know the length of AC. Do we know the length of BC? Same again, theorem 5. Again, this question is based on theorem 5, which is perpendicular drawn from center bisects the chord. So this means our AC equal to BC equal to half of AB, right? So our AB will be, AC is 12 centimeter, BC will also be 12 centimeter, and AB is then going to be 24 centimeter. So this one also was pretty simple. Now, so far, all these questions were based on that same one theorem, theorem 5. So here I've written by theorem 5. And did I write here? Yes, here also theorem 5, this third question. This one is theorem 9 because it talked about arc. This is also theorem 5, I guess. Did I write the theorem? Yes, theorem 5. So out of the 4 questions so far we have done, 3 were based on theorem 5. So this is something which you need to remember very well. The perpendicular distance from the perpendicular drawn from the center to the chord will always divide the chord into two equal halves, or we can say it bisects the chord. This is very important theorem that you should remember. So we'll close today's video here, and we will continue with this exercise in our next video. Till then, learn the theorems well, keep practicing, and enjoy learning maths. Bye bye.